Hi friends, welcome to another episode of Declutter. In this episode, let's look at this very interesting topic of Cayley-Hamilton Theorem and see how we can use it while solving certain questions in matrices and determinants. Let's first understand what the theorem does and then look at a couple of problems. So what the theorem states is, if you have a matrix A, which is a matrix of a 3 by 3 order, then there is a characteristic equation for the matrix which can be determined when we solve for A minus lambda I is equal to 0. When we solve for this equation, we will get a certain equation in lambda which will be of the form lambda cube minus A1 lambda square plus A2 lambda minus A3 equal to 0. The lambda that we get here, these are called the eigenvalues. What Cayley-Hamilton theorem states is that this characteristic equation that we get when we solve for lambda, the same thing can be transformed into the matrix form and it will be read as A cube minus A1 into A square plus A2 into A minus A3 into I is equal to 0. And this is what we will be using to solve some tricky equation looking questions in matrices. Now the question is, what are the values of A1, A2, A3? When you actually solve for det of A minus lambda I equal to 0, the coefficients that you get are as follows. A1 is nothing but the trace of A, which is the sum of diagonal elements of A. A2 is nothing but the sum of minor of the diagonal elements. This is sum of diagonal elements. This is sum of minor of diagonal elements. And A3 is determinant of A. And this is how you get the values of A1, A2, A3. What you need to pay attention to is, I have switched the signs like we do in a quadratic equation when we apply sum rule and the product rule or any multinomial theorem. And these will be the values of A1, A2, A3. A1 is sum of diagonal elements, A2 is sum of diagonal minors, and A3 is the determinant of A. Let's see how this can be used to solve some of the questions. Now this is a question that is a PYQ from JEE 2024. Before I studied about this theorem, I would get overwhelmed when I saw matrix equations, because my first thought was, do I have to actually solve for A cube, A square and all? But no, we don't have to do that, because the trick lies in writing the characteristic equation in matrix form. Since this is a 3 by 3 matrix, I know the characteristic equation can be written as A cube minus A1 into A square plus A2 into A minus A3 into I equal to 0. Let's see what A1 is. A1 is the trace of the matrix, which is 5 plus B. A2 is the sum of the minor of the diagonal elements. Let's do that. 3, 1, 5B plus 2, 0, 0B plus 2A, 1, 3, which will give me 3B minus 5 plus 2B plus 6 minus A. So I have 5B minus A plus 1 as my A2, and my A3, which is nothing but my determinant, can be formed simply by doing 2 into 3B minus 5 minus A into B, because the third term will be 0 and if I find the minor of A, it is 1B minus 0. So this is equal to 6AB minus 10 minus AB. Sorry, 6B minus 10. So when I plug this into this, I get A cube is equal to A1, which is 5 plus B A square minus A2A, and A2 was 5B minus A plus 1 minus 5B minus A plus 1 into A plus A3, which is plus 6B minus 10 minus AB into I. And if I compare this with this, I can say 5 plus B is 4, that will give you B is minus 1, and 5 into minus 1 minus A plus 1 is 1, which will give you 1 and 1 cancel. A is equal to minus 5, and let's verify whether the 21 holds true or not. So when I plug these values into here, I'll get 6 into minus 1 minus 10 plus 5 into minus 1, which is minus 21i, and that holds true. So we have found the value of B as minus 1, and the value, so this is minus 10 minus 3, which is going to be minus 13, and that solves our question. Technically speaking, if you realize, we never had to find the value of A3 because it was just for the sake of checking the final answer. And that is how we apply Cayley-Hamilton theorem to solve questions in matrices. I hope you like this video. Go back to your PYQs, go back to your resources. If you come across a question which you're not able to solve that is in equation form in matrices using Cayley-Hamilton, come back to me in the comment section and we will pick it up. I hope you enjoyed this. If you did, do like, share and subscribe.